Hey everyone. So in this video, I'm going to just talk about how you, in practice with problems on homework or on exam, go ahead and use the formulas for arithmetic and geometric sums. So these are two different formulas, and they correspond to different kinds of sequences, the arithmetic sequence or geometric sequence. So let's see a typical problem that you might run into here. So we'll just jump right in and say we're asked the following question, uh, which is to find the sum of the first 40 terms of the sequence, we'll say 3, 7, 11, 15. Okay. So you're asked a question like this. And now the first thing to do in your answer is to determine what situation you're in. So step one is maybe let's find the sequence. Notice that this is an arithmetic sequence. So, and the way you notice that is, well, we're talking about two different kinds of sequences here. And how are you going to find out which state you're in? An arithmetic sequence is you're using the arithmetic of adding to create the next term. So you have, if you want, you look at this term and you say, how do I go to this term? Well, you may have to look for a minute, but you'll see, well, the difference between these two terms is 4. 7 minus 3 is 4. 11 minus 7 is 4. 15 minus 11 is 4. So the differences in between each terms is 4. So you get this common difference. And you can say, this is because there is a common difference of 4. If you notice that that number is changing, then you're not in an arithmetic sequence. Great. So now you want to apply the arithmetic sum formula. You don't want to go ahead and try to continue writing out the sequence all the way to the 40th term. It's just much better to apply the arithmetic sequence formula, or arithmetic sum formula, pardon me. Which is going to be that the sum is equal to P naught. This is just the formula, and I'll explain how we get these terms. P naught plus P n minus 1 over 2, and then we multiply this whole number, usually in the numerator, by n. Okay, so let me explain what this formula is referring to and how we get it. So, this formula is a formula that gives us the sum of the first n terms. Oops. But in order to know this formula, we need to figure out what the 40th term is going to be. So the 40th term is going to be, so P sub 39 is the 40th term. Now, this is just something that we have to get our heads around, and the reason it's this way is because we are using this population sequence notation. So the first term has a subscript of 0. which means the, second term has a subscript of 1, and the third term has a subscript of 2, and the 40th term has a subscript of 39. So it's a little bit strange, but it's something we can get our head around. But now, how do we find that term? Well, um, we can just say that we have to use the formula for the arithmetic sequence. And so we notice that we found the common difference of 4. And so we notice then that P of 39 is equal to P sub 0 plus 39 times 4. Okay, um, this is the arithmetic or the explicit formula for an arithmetic sequence with common difference 4. Now we can go ahead and put in our P naught value. What is P naught? P naught is this first value. So P naught, oops, P naught has value 3. And from this, we have all of the ingredients we need. We just need to calculate a little bit. All right, so what are the ingredients we need? We need P naught, we have it. We need P sub 39. We have this, but we need to calculate it. Okay, so let's calculate it. P sub 39. I can put P naught in, so 3 plus 39 times 4. And then we go ahead and use the calculator. We'll have 39 times 4 equals 156. We add 3, and we get 159. Great. So now we have both ingredients that we need here. We have P naught equaling 3. We have P sub 39 equaling Pn minus 1. N is 40 because we are trying to sum the first 40 terms. Okay. And so we go ahead and put all of those ingredients into our sum formula. And we'll get that the sum is equal to 3 plus 159 times 40 all over 2. So we've already got the 159. Let's add 3. And then we're going to multiply that times 40. And then we're going to divide that by 2. And we'll get our answer here at 3,240. Whoa. I didn't know I could do that, actually. Let's box our answer. Okay, so there were a few steps in there that I'd like to just review real quick. The first step was to notice what kind of sequence we're in. We have an arithmetic sequence. And right there, I could have said, all right, well, since it's an arithmetic sequence with common difference 4, I know I have a formula like this. In fact, I have a more general formula of P naught plus, well, I can write it down. The more general formula is going to be P naught, or P sub n equals P naught plus the common difference times n. That's the general formula for the arithmetic sequence. So I wanted that because I was asked to find the 40th term, or at least the sum of the first 40 terms. So I needed to actually know what that 39th piece of 39 is, or the 40th term. So knowing that then allowed me to compute here and then just plug those values in for the formula. Okay. All right, so let's do another one, but let's do a geometric sequence. So let's try this. We'll say question, find the following sum. Maybe following, yeah, we'll say following sum. We'll say 1 plus 3 plus 3 squared plus 3 cubed, all the way up to 3 to the 8th power, let's say. Okay. Okay, so now what do we recognize about this? Well, the terms are the summons 1, 3, 3 squared, 3 cubed, on and on. Those are in a geometric sequence. So let's just make that observation. So answer. So observe that 1, 3, 3 squared, on and on, this is a geometric sequence. So what we're dealing with here is the geometric sum formula. And let's go ahead and recall the formula, the explicit formula for the geometric sequence. So with explicit formula, P sub n equals, well, in this case, 3 to the nth power. Okay. Now, what is the geometric sum formula? So the geometric, well, let's recall, geometric sum formula is that if I sum the first terms, so this is P naught plus R times P naught, yeah, let's put the P naught, pardon me, R times P naught plus R squared times P naught plus dot 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 plus R to the n minus 1 times P naught. This sum is equal to, let's move this over a bit. This equals R to the n minus 1 times P naught. So this is this geometric sum formula. So what do we have here? Well, we have to identify, we have one of these types of left-hand sides. So this left-hand side needs to be matched up with this expression. So we need to find a few different things. What do we need to find? So we need R, we need P naught, and we need N. So we need to be detectives for a moment and find all three of those values. So you can see that P naught is 1. And that also follows from looking at this kind of a formula, is that when we look at n equaling 0, this is 3 to the 0, that's 1. So P naught, we're good. We can say that's 1. R is sort of the base that we're exponentiating. So R is what we're seeing in the powers. So we have R in the second term, R squared in the third, so on and so forth. So R squared, R cubed. So R in this case is going to be 3. And N is just how many summons we have. Okay, how many do we have? Well, let's see. I've got 1, 2, 3, 4, all the way up till, you might say 8, but in fact 9. Let's recount that again. This is my first term. This is my second. This is my third, fourth. So what you'll see is that the exponents are one ahead. So first term, second, third term, fourth term, ninth term. Let's just make sure. and write it all out. That way we don't feel like we're missing something here. Sometimes those dots are not necessary. So this is 3 to the 4th, 3 to the 5th, 3 to the 6th, 3 to the 7th. Okay, let's count. First, second, third, fourth, fifth, sixth, seventh, eighth, ninth. And the point is that this exponent is one less. That's one of the reasons why these a minus ones are happening all over the place. So n in this case is 9. I've got 9 terms I'm summing together. Now that we have all of those particular terms that we need for our formula, we go ahead and put them in. So the sum is equal to 3 to the 9th minus 1 times 1 all over 3 minus 1. So I switched calculators, and that way I can get 3 to the 9th. Now let's go over and take a look. I'm going to clear this, and I will use the 3, and then this x to the y is what I'm going to use here, and then I'll put 9 in here, and I will get this value for 3 to the 9th. And that will give me the numerator, but I can actually subtract off 1 from that, so let's do that. Minus 1, that will equal this value, and then I will divide by the denominator, which the denominator is 3 minus 1, or 2. And get this value. And that is 9,841. All right. So hopefully that helps folks use this formula to calculate these sums.